Good morning to all. Today we are doing some questions on miscellaneous exercise chapter 5. So our base is from NCRT and some other sources. Let us do some important questions from NCRT and some other sources. They will be helpful. They are very important for examination point of view. Question number chapter 3, question number third question we are doing here. In question number 3, find the value of x, y, z if the matrix A satisfied the conditions. We have given a matrix in these questions. We have to find x, y, z. And here given matrix A 0x, its entry is 0x and x, and second column entries are 2y, y and minus y. Third column entries z, minus z and z. So this is the given matrix A. Under the given conditions, we have to find out x, y, z. If it is given that if A and A transpose, if transpose A and A is equal to identity matrix. So this is our question. So we have to find out the value of x, y, z. So under the given condition, transpose of A and A is identity matrix. Since it is a square matrix of order 3, so our identity matrix will also be a square matrix of order 3. Now first we just find the transpose of A, then multiplied of these ones. In the left hand side we have given transpose of A. So we have written the transpose. Our answer start here. Now transpose of A, row becomes its a column. Now first row is 0, 2y and z, and second row x, y minus z, and our third row becomes our third column x minus y and z. And multiplied with the matrix of A. This is our matrix A, and its entry are 0x and x, 2y, y minus y. This is z minus z and z. So this is equal to, according to the question, identity matrix. This identity matrix has order also. Here 1 0 0 0 1 0 and 0 1 0. So its a diagonal should be 1. It is a scalar matrix also. Identity matrix known as also scalar matrix, also a diagonal matrix. So diagonal entries is 1. All are equal to 1. So in the given condition of the diagonal matrix, all non-diagonals elements should be 0 and diagonals are non-zero. At least one entry should be non-zero. Then it is called a diagonal matrix. This is also diagonal matrix. Now this is our given conditions. This is matrix A. We have just written I barabar this one. Identity matrix will be this one. So I have written this value. Now just using the matrix multiplications, we have row. First row, if I multiply this ones, first row multiplied with first column. So here, if I multiply first row over, this is first row and this is first column. Just corresponding entries should be multiplied this one. 0 into 0, let us do, and plus x into x plus x square, and x into x is also x square. Now first row, second, this is first row, this is second columns. Just this entry should come here. Second row, and this is first row and second column. This entry should be here. So now just multiply this one. 0 into 2y, 0 into 2y will be 0, and x into y will be plus xy, and here x into minus y will be minus xy. Now and third entry of the first column will be not first column, it will be first row. This is the first one. Third column will come here. So 0 into z will be 0, and x into minus z minus xz, and x into z plus will be plus xz. So this is our first row entry, and written in the square bracket, and outside is identity matrix. Now second row. Now we are doing this. We have to fill these ones. This is second row in first column should come here. 2y into this 0, and y into x will be xy, and here minus y into x will be minus xy. Now we need this entry. This entry should be filled second row, second column. This is second row, this is second column. So just multiply this one. 2y into 2y will be 4y. 4y and y into y will be y square, and this into this minus y will be plus y square. Now this entry we are to fill this entry. So this is a second row, third column. This is second row, this is second row and third column. Our second row is this one, and third column will be this one. Third column will be this one. Now 2y into z, 2yz, and y into minus yz, and minus y into z is also minus yz. Now we have to fill third row. This is our third row and first column element. Now third row should be from here, first column will be from here. Now this is our third row. Just multiply these entries, multiply this one, first column of this one. Z into 0 will be 0 plus minus x, and this to minus xz, and z into x will be zx plus xz. And now this entry will be filled by multiplying third row and second column. This is third row and second column will be this one. Now y should be multiplied this one, 2yz, and minus y, and this value minus yz, and this into this minus yz also. Now this is the last entry of third column, third column and third row. This is third row and third column of this one. Now y, z into this is our z value. Z into z will be z square, and minus and this into should be multiplied. This z square, and this into z plus z square. So we have multiplied left hand side, and our right hand side is this one. So this is a identity matrix, and its entry is are 0 and 1. So 1, 0 and 0, 0, 1 and 0, 0, 0 and 1. These are the entries of the identity matrix. Now both are same orders, and both are equal. Both matrix are equal. Then we have to equalize the corresponding entry. Now this entry should be equal to this one. Now if I compare these values, so now this should be equal to this one. Now from here, x square is equal to 1. If you solve this one, 2x square is equal to 1, and from here x square is equal to 1, and then x will be plus minus 1. So now we need you also x, y, this 0, this also 0. We need values of y, so only the diagonal element should be equalized right hand side, because other entries are 0. So now here 4y, we have to equalize this into this. This should be equal to, now second row, second column element should be equal to this one. Now using this one, 4y plus y square will be 2y square is equal to 1. is equal to 1. This is the quadratic equations, and now we have to solve this quadratic equations. How to solve this one? Just 2y square plus 4y minus 1 is equal to 0. This is our quadratic equations. Now how to solve this one, sir? If middle term is splitting or not. Middle term is not splitting, then using another formulas. So now there is some correction needed here. Second row, first column. 2y into 2y will be 4y square. 4y square, y into y square minus y will be this one. It's okay. And here, so now this value becomes 4y square, 5, 4, 5, 6. This is 6y square. So now this is not a quadratic equations. So there is a so here x square will be 1 by 2, and from here x is equal to plus minus 1 upon root 2. Now here 4y square and 6, this will be 6y square. 6y square is equal to 1, and then y square will be 1 by 6, and from here y will be plus minus root 6. Now we need the third entries. Now for this one, z square, z3, z square will be equal to 1k. So therefore for this value, and if I equalize this and equal to this, so this comes out 3z square. 3z square is equal to 1. From here z square is equal to 1 by 3, and from here to z is equal to 1 plus minus root 3. So now our answer comes out. So our values are from here to x is equal to plus minus 1 upon root 2, and y has the value plus minus 1 upon root 6, and our z has the value plus minus 1 upon root 3. So this is our answer. Now question number 4 of this exercise. In question number 4, for what value of x there is a product of the matrices 1 to 1. This is first matrix. Another matrix is whose entries are 1 to 1, 2, 0, 0. And third column 0, 1, 2. And multiplied 0 to x. Is equal to 0 matrix. So 0 matrix. For 0 matrix, what should be the order of the 0 matrix? Here, look at question number 4. Now here order of first matrix is first rows 2 column, first row 3 column. Now second matrix has 3 cross 3, and fourth matrix has the order 3 rows 1 column. 3 rows 1 column. So here in this case, if I do this one, product of first matrix, okay, this is a common, here is also common. We should have final answer comes out 1 cross 1. So our answer will be, our matrix should be 1 cross 1. Only 1 cross 1. So it means that there is only in 0 matrix only 1 entries. This is first row and first column. So let us suppose first multiply by first two matrix. We have to multiply first two. So here multiplied first two matrices. Now first row. First this is first row and first column. Just multiplied here. First this is first row and first column, and 1 multiplied 1 here. 1, 2 into 2 4, and 1 into 1 is plus 1. Now this is a first row first column. Now second row second column would be here. This is first row second column. 1 into 2 will be 2, and 2 into 0 will be 0, and 1 into 0 will be 0. Now first row and third column. 1 into 0 will be 0 here, and 2 into 1 will be 2, and 1 into 2 will be 2. So this is first row. Now so this is only one thing we have. Multiplication of first row matrix has this one. First row matrices multiplication comes out this one. So since we have only one rows, now increase number 3. Now 0 to x, its increase will be like this, and we have only one increase in the 0 matrix. So here it is first row. Its order is first row third column, and its order is three rows first column. So we have, this is common both. So we have it's a column and its rows are the same. So our matrix will be 1 cross 1. So just one increase should be here. So first row multiplied first column. Now it becomes, just first we have to simplify this one. 4 plus 1 plus 1 is 6, and this is 2, and this is 2 plus 2 is 4. Entries of third matrix 0 to x. We have to find out the value of x. Yes, we need to find the value of x. So now this is the value. Now multiply these ones. 6 into 0, 2 into 2 is plus 4, and 4 into x will be 4x, and this is the entries of this matrix should be equal to this one. So here 4 plus 4x. So we have 4 plus 4x is equal to 0. Now 4x will be minus 4, and therefore x is equal to minus 1. So this is our answer. X is equal to minus 1 will be its value. Now this is question number 5 of miscellaneous exercise on chapter 3. This is matrix A. Show that a square minus 5a minus 5a is equal to plus 7i. The identity matrix is 0. Now first we have to find out the value of putting the value a square, then minus 5a, then 7i, and simplify this one. So what it comes out to our left hand side. First we have to prove, we have to find out the value of a square. A square will be just multiplication of the 3 minus 1, 1, 2. This is matrix A. Another matrix 3 minus 1, 1 and 2. So if I simplify this one, this is a 2 cross 2 matrix. Again comes out 2 cross 2. Now first rows. This is first row first column. 3 into 3 9, and 1 into minus 1 minus 1. Now this into this, 3 into 1 is 3, and 1 into 2 will be plus 2. Now second row first entry, minus 1 3, and 2 into minus 1 into 3 minus 3, and 2 into minus 1 will be minus 2. Now this multiply this one, minus 1 into 1 minus 1, 2 into 2 is plus 4. So this is the square of A. Just if you simplify this one, so 9 minus 1 will be 8, and minus 3 minus 5 minus 5, and 3 plus 2 is 5, and the minus 1 plus 4 will be 3. So this is square of A is 1. Now if I put all values in left hand side, So our value comes out. Now the left hand side, our left hand side is equal to a square minus 5a, a square minus 5a plus 7 into identity matrix. Our identity matrix, matrix A has the order 2 cross 2. Identity matrix should also be 2 cross 2. If I put all values here, a square has this one, 8 minus 5, 8 minus 5, 5 and 3, and minus 5 into matrix A. Matrix A has the value 3 minus 1, 3 minus 1, 1 and 2, and plus 7i, 1 0 and 0 into 1. Now this value comes out. Again, if I check a square whether it is correct or not, first row first column, 3 into 3 9, and 3 into 3 will be 9, and this minus 1, okay, and this into this 3 and 1 2, and first row second row first column, minus 3 and minus 2 and minus 1 and 2 into 2. It's okay. Now just simplify this one. First we have to multiply the entries of this matrix by 5 and entries of this matrix by 7. So it comes out 8 minus 5, first column element, 5 3 the second column, multiplied each entries by 5, 5 into 3 15, outside is minus 5 into 3 15, and minus 5, and this is 5 and this is 10, 5 and 10, bracket is closed, multiply 7 and 0 and 7. So we have to prove this comes out should be 0. Now if you simplify this one, it comes out. So now we do it here. 8, this is plus and plus, 8 plus 7 15, 15 minus 15 will be 0. This is 5 minus 5, and 5 minus 5, 5 outside is minus, 5 minus 5 and plus 0, it again 0, 5 minus 5, and third entry is of the second row first column, minus 5, this is there is something wrong, 10, yes, minus 5 is here, minus 5 minus plus 5, and next one 3 minus 10, plus 3 and plus 7, plus 3 and plus 7 plus 10 and minus 10, plus 3 plus 7 plus 10, and here minus 10. So you we have find out this 0 and this 0, this comes out there, all are cancelled out, 0 0 0 and 0. So we get the right hand side, this is 0 matrix. We have proved that the left hand side is equal to the right hand side.